So today we'll be talking about chapter 11 and 12 from Rust book. First of them being writing automated tests, the other one being an IO project, CLI command line, as Alex has said. So let's go to the automated tests. Just with this presentation, I didn't follow the layout as it was presented in the book, to be honest. And the reason is that I didn't find it so clear, at least for me. So I tried something different, and let's just see how it goes. I did basically, I do basically cover the same topics, it's just in a kind of a different format. Yeah, so they did start it with some kind of motivations, why testing, and I guess all of us know that the tests are pretty good. And the reason is that they kind of ensure correctness of the program, especially the logic of the program, right? Even though the like Rust, C++ as well, right? They are strongly typed languages. So they kind of enforce the type correctness. Obviously, there is nothing in a program, in a language that can say that your logic, business logic is correct. And that's why you basically write some tests to it. They also serve you as documentation. While writing a test, you also are testing your code, production code. You are being the first user of that code, which is also good because you also try to look at it from the different perspective. Once the test is written, they can be used as a regression indicator. Then when it's combined with approaches like TDD, apparently you're improving the design and they lead to implementing minimal necessary functionality. It's just like probably you can find many more. It's more than the book has said, just kind of motivation to start with, right? So the first thing I wanted to talk about is just what the Rust test function is. And because that's a basic building block for every Rust test suite that you run in Rust. And basically that function is just a normal Rust function that is annotated with the hash test attribute. This is just the attribute is just the metadata about the code itself that is visible during the compilation. Then the function takes no arguments. And there are two options. Either that test function returns a unit type, basically nothing. And in such a case, the test is considered to pass if it just finishes. If the function finishes, the test is considered to fail when the test panics. And I put some asterisk here because there is like an exception from that rule. Otherwise, there is another type of that test function, which is the function returning result variant with a unit type as a success and then the error type as the error. And just to mention something, so all these tests, because they are annotated as a test, then the leap test that is like in Cargo library, it will be able to detect those tests and run them in a test suite. So if we try to look at the test function with a return unit type, so the simplest function looks like that. So basically, it's annotated with the test attribute. The name of a function takes no arguments, returns obviously a unit type. And then the simplest one is just if it doesn't have a body. When the test runner executes it, it just enters the function, exits the function, it considers it as a success. However, if the function panics, then the test runner will consider it as a failed test, and it would be giving you some kind of error like this with the information why it has failed. Then I did say about the asterisk. So there is an inverse rule. So you can write some tests that are testing if your particular part of the code does panic, because that's your business logic. You want to panic, and then you are able to annotate the test function and say it should panic. And if it does panic, then it's considered to be success. Otherwise, if you are expecting it to be panicking and it does nothing, then your test run would say, no, the function has failed. As a kind of, so your functions that you are testing, they obviously can have multiple points of failure and multiple panic messages. And to cover that, the test functions in Rust, they can have an expected parameter to the should panic function, which basically is a substring that it expects to be inside the panic message that is being thrown. And in such case, the test function that does panic would succeed if the succeeds, in this case string, would be a substring of a panic message. And it would fail, such a test would fail if the test either didn't panic or it panics with a message that doesn't have a substring in the information in the panic message. So, and the test runner would give you an exact information why it happened. So it would say that it failed with a message like so, but it doesn't have a substring succeeds in that particular message. If we are to consider the Rust test functions that are written in the result type, then basically such a function is considered to succeed if it returns okay. It's considered to fail if it returns the error variant. I personally, when the test runner prints the error message, I personally don't find it too. So it prints lots of error lines, but really, like, kind of one line is really useful. So not sure how much useful the whole result thing is, but apparently it is useful when you are testing some kind of functions that can return a result type, and then you can use question mark operator to do some shortcutting, and then have more concise test code. So if we're talking about the test functions, then obviously what I just shown is in those test functions, those are kind of the bodies that are very simplified for the presentation purposes, right? But you would normally have some kind of if else's and then throwing panics potentially to fail the test, whatnot. And to make it more readable, then Rust introduces some kind of assertions, which you can use in assert part of your arrange, act, assert body of a test, really. And when you are using assertions, they are helping you to express better the intent of the test. The test becomes more concise because then you get rid of some pattern matching or if else's and whatnot. And those are also improving the error messages once the test fails. So it gets you quicker to find the reason of a failed test. And Rust itself, like the standard library, it introduces three assertions. One of them is just so macros. One of them is just assert macro, which asserts on the Boolean value. If it's true, then it wouldn't trigger panic. If it was false, then it would trigger the panic with the appropriate message. Then you have two equality assertions. One is assert equal, that takes two arguments, and it expects them to be equal, otherwise panics. Assert not equal, which takes two arguments, assumes they're not equal, otherwise it does panic. Yeah, so when you're using these assertion macros, then the message in case of the failing test seems to be more concise and nicer. So in case of the assert, you would just assert on the Boolean value. This test obviously is written so that it does fail, and we can see what kind of the error message it would give. Then you still can improve the error message by adding a format format macro string with additional parameters if you wanted to, so that it can print, give you more human-friendly information. Obviously, that is already like more writing of a code. So I guess lots of the users, lots of the developers would still choose such an assertion without more lines of code. But if you really wanted to give some more information in case the test fails, you would choose that form of the assert macro. In case of the assert equal, again, you just give two arguments that are meant to be equal. If they're not equal, then you would have the information saying that assertion has failed, left value didn't equal the right value with the information what the left and right are. Obviously, those have to be equalable to each other, so they have to implement partially equal trait. And to be able to print that information there, then they have to implement debug trait. Again, as with the assert macro, you can have the other form of the assert equal, where you again give a format string with the appropriate number of arguments expected by the format string, and that would print more readable information about why the test has failed in case of a failure. Very similarly for assert not equal macro. So if it takes two arguments. If it doesn't equal, or if it does equal, because it's expecting not equal, then you would be getting an appropriate information that it has panicked because of equality of the arguments. And there is yet another form taking the format and the values expected by the format to give the error message even more user-friendly. And as I did say, so for the assert macros, assert equal and assert not equal, your type that you are putting inside as the argument, it has to implement partial EQ, and debug traits. And often to implement such types, such traits, often you just can use derive attribute, forgot how it's called, on your type. And most of the time you just can run away with such line of code to satisfy that requirement. And if we're talking about the assert macros and the readability of the error messages and whatnot, then in Rust, in standard library, there is almost assert match being implemented. If you follow the link to the GitHub, they basically say that it's already stabilized and is gonna be released soon. Or you can use some crates that have even better assertion errors information, like for instance the claim crate, which improves the comparison assertions. So it gives you more assertions like expects arguments to be greater than, greater or equal, less than, less or equal. Or it can assert on the specialized errors. So it can give specialized errors for the return types like result, option, and poll. And with Rust, if you wanted to import any like a crate like that, and that crate is only used for the testing purposes, you in your cargo toml, you would put it under the dev dependencies section, so you don't spoil your dependencies during the runtime, but they would be only pulled during the test execution. All right, so that was kind of the discussion about the basic building blocks, which are the Rust test functions, right? And then obviously on test functions on themselves, they're not very useful. So you need to have some kind of the test harness, test runners. And this is what Cargo is implementing for like the normal and probably like 80–90% of the execution of the tests in Rust. And Cargo is allowing you to write four type of tests. One of them is the unit test. The other one is the doc test, integration tests, and the benchmark tests. So the book hasn't been really talking about the benchmark tests. And the reason is that this is not in the stable stable version of the compiler. I think it is like supported by Cargo, but not by the compiler. You have to toolchain. You have to be on the nightly build. So probably once it gets in, they will start also writing about it in the book. So I'm gonna be skipping it. The doc test itself is like a really, it can be either a unit test, integration test. It's just the location of where the test is being put. And I will discuss that shortly. So yeah, if you just before we start, once you write some tests that we will discuss further, the way how you run your test and see the results is just by saying cargo test. If you want some more information about what cargo test takes, you can just do cargo test dash help. And the reason for that is that this dash is a separator, and it will give the lib test argument help so that the lib test is giving you really the information about the help. So just a piece of information I found useful, basically. So when you run cargo test, it's not so the steps that happen is that you are building the library of your crate, you're building all the beans of your crate, and there is like a condition, but I wouldn't worry about that, right? So you build lib, you build all the beans, and you build all the examples, and then you build lib again and the beans again, but then they are built in the profile test profile. So basically that is being built twice. Then you build all the integration tests. Then you're building the doc test, and the building of the doc test is basically extracting the doc test code and linking it against the lib. And you're building also the bench test, but we're not gonna be talking about that. And after all of this is done, you're running the tests. So there's lots of steps when the cargo test is being executed, and I think it's useful to be aware of that. So if we're talking about those three types of tests that Rust, the default Rust with cargo is giving us. So the first one we did mention is the unit test. And the unit test is just a test that is testing a unit of your code in the isolation. So basically, you're just having a function, you're just having some kind of few sets of functions being invoked at the same time, and you're trying to feed it some information, and then you assert expected result on it. And those tests are kind of embedded with the code of the beans and the library of your crate. Usually, but it's not like the rule that you have to follow, but usually they are embedded inside the tests module. But what you have to be doing, or what you should be doing, is you should be protecting it with the test config annotation. And the tests, so the test functions that you're writing, they have a visibility to all the code that the normal functions of Rust would follow if they were inside the sub module of some parent module, right? So that's why you can do a white and black box testing with the unit tests, because you have access to execution of non-publics, or you have access to non-public structures, non-public functions. When you are putting the unit tests in your standard project layout, you're basically putting those unit tests inside any, you can put those unit tests inside any Rust file in the source directory, either in the library, either in the main executable, or any secondary executables of your crate. And the way how it looks like is that on the example of the library, you would have a production code, which is private code, function, and potentially a public function. Then you would add the module test with that configuration attribute or guard. Yeah, so conditional compilation attribute, which means basically the compiler is not gonna see this code if the compiler or if cargo is not executed with the test profile. When the cargo is executed with the test profile, or cargo is executing compiler with the test profile, then it would also see that code and execute those functions. And this is useful because when you're not interested in running the test, you don't really want your compiler to be spending the time on on parsing of that kind of the code, on compiling the code and whatnot. And you also don't want your binaries to be bloated, basically, right? Then, as we did mention, usually you put your test inside the test module. I think, in fact, in the previous test, in the previous slide, I said it was the tests module. So I don't. Yeah, and you would basically say, I want to have these functions to have the visibility in everything on my parent module. So this is like the convention that people are using. And you would just be running normal Rust tests with some assertions on what you want to be checking. And as we said, the unit tests, they do have access and they can test the private function, or sorry, public function, and they so ask2 priv should be put here, but they also have a option to be testing the private functions, right? I didn't realize there is an error on that slide. So when you run cargo test and you're looking at the section that gives you unit test information, then you would be able to see that it's running the unit tests inside your main library. It's running the tests inside your, it's running the test inside your library. It's running the test specified, the unit test specified inside your main library. And it's also running the tests specified inside your secondary binaries. And yeah, so the second type of the Rust tests is the doc tests, and this is basically embedded in the code comments in the markdown in the form of the markdown code blocks. And the reason of their existence basically is so that they are visible as the code that can be copied in and pasted inside the Rust file and then just compiled by the user. So usually they're just small examples, but functional examples. And the reason why they're really nice is that during the cargo test execution, those pieces of code are being executed as well. So you're not gonna get into the situation where you had a test, where you had an example in your documentation, and then you forgot to update it after you changed some part of the code. Where do you put the doc tests? You basically put them anywhere that the library part of your crate. So when the library part of your crate is being compiled, and whatever modules that library crate contains, then you can put the doc tests in there. The way how it looks like is that obviously you have a doc comment on your function, and then you put the markdown code block inside that function, and then you write the code that would be extracted to be compiled. One of the things that you can also add there is that you can prefix the lines of the code with the hashes, and it's not a comment, it's just something indicating to the cargo doc that those lines shouldn't be visible inside the documentation itself. So for instance, for this example, even though the code being compiled to test the add2 function is those 4 lines of the code, when you run cargo doc, it will produce just the 2 lines of the code. And it's useful in multiple situations, especially the situations where you want to do some tries on the execution of the code. When you run cargo test with the doc tests, there will be a section saying the doc tests run within the cargo tests consist of multiple tests from different parts of your library code. and there will be information that it has passed, right, and what function it was annotated with. And then there is a third type of the tests with Rust, which are integration tests, and they're basically the tests that are testing the library, but also the binary of your crate. But the testing of the binary is a little bit more complicated. And you write those tests and you use the code from your library of the crate as if you were just a third-party client, so you can only use the public API. And it's just a complementary thing to the unit tests, right? The way how you add integration tests to your project is that under the test directory, any Rust file that you're specifying with the test function, Rust test functions, it will be compiled as a separate binary that will be run by the cargo test eventually. So inside the example inside the directory, you would normally, if you wanted to bring the add2 function from the other crate, you would just bring in that crate inside the scope, and then you would call other add2 on the crate, and you would validate that, or you would do whatever validation you wanted to do on it. A thing worth mentioning, like unlike with the unit tests, you wouldn't use config test attribute here. The reason for that is that you're building integration tests really only when you want to build the tests. They're separate, they are separate binaries, so you're not bloating the code of your binaries. But obviously, it's still a test, so you should annotate it with the test attribute. When you run cargo test containing integration tests, you will be able to see that it runs every binary. So compiled binaries for every RS file with the information on what tests it contained, what tests it have been run, which failed, which didn't fail. Yeah, and with the integration tests, so once you start writing integration tests, there is gonna be a need for you to reuse the code. And one of the tempting thing would be basically to put like a common module maybe under the test directory with, let's say, the setup function that you would want to use inside multiple integration tests. However, if you do that, you would end up with a working code, but the cargo test output would also try to run the common module as a test integration test binary, which obviously doesn't have, or yeah, most probably it wouldn't have any tests in it. And that's not something you would really like. So to make it clean, they suggest of just adding a module inside the test directory with the mod RS in it. So Rust would still know, or Cargo would still know that this is specifying the module that you can use in the other tests, but it wouldn't be treated by Cargo test as a integration test binary. So you wouldn't be polluting your cargo test output. There is a problem with this setup though. They don't mention that in the book, but Luca Palmer in his Zero to Production, he goes kind of in depth with this problem. So basically, once you start sharing that one module, maybe consisting of multiple files, and you have many functions in it, but only a subset of those functions are used in one integration test, and then the subset of those functions is used in the other integration test. During the compilation of the tests themselves, you would get warnings about never used functions. And the reason of that is that those integration tests, they are independently compiled from each other. So the compiler would see that it has public functions in the module while compiling this guy, but the functions are not being used. So for it, it's a dead code. And there are solutions for like overcoming it. So obviously you can have also the integration test specified as a binary with my main RS, and then so consisting of multiple RS modules. Rust modules, but none of them is really like ideal, I think. And yeah, I'm not gonna be going into that. They didn't mention that in the Rust book. Luca Palmeri does mention that. Worth reading the book, I think. It's worth reading anyway. Yeah, so if we're talking about the integration tests, I did mention that most of the time it's testing the library, the part of the crate. And if you have the bin binary crate, then what people tend to do is that they have a mixed crate, which consists of the binary, which is just a thin wrapper around extracted library code, and then they would be mostly integration testing the library code itself. However, you still can write integration tests that are being executed against the binaries themselves. And if you wanted to do that, you can use crates to help that can help you in writing less code to do so, like assert command test binary. And what they basically do is that they do execute the binaries of your crate with obviously command line arguments, and then they do some assertions on the standard output, standard error, and on the result code. What is mentioned in the book is that there are different ways of running cargo tests, and that gives you more control on execution of the tests. One of them is, for instance, you can choose how many test processes you want to run, or test threads you want to run. So normally what happens is that once the tests are being run, the test functions are being executed in multiple threads, and then those threads execute, either they succeed, fail, and then the main binary is collecting results and eventually is going to be printing it out. And obviously, if it's being executed in multiple threads, and by the default number of threads is the number of CPUs that you have on your computer. But for some reasons, maybe if you don't want to kill your, so you don't want to slow down your computer because you're doing something, or maybe you have bad tests that are kind of not independent from each other, but you still want to just run them right now. So you can change the number of threads that you want to run it with, and there is an argument test threads for it. You can also, so when cargo is executing the test, it's not, even if the code under test is printing something to standard output or error, is not going to show on the result of cargo, because cargo is just kept intercepting that output and remembering it. It would print it, the standard error or the output, if the test fails, but in case it doesn't fail, it's not going to be shown. If you do want to show it, you just specify it with the show output argument. And then if you can use yet another attribute on the test functions, you can say, hey, ignore that test. And when you do cargo test, the tests with the ignore attribute, they wouldn't be executed. If you want to execute them, you have two options. You can either run cargo test with the ignored, and then it would only run ignored functions in your test suites. Or you can, if you want to run all the tests, you can say cargo test include ignored, and then it would run all the tests. And the last thing I think that they did mention is that you can also run just a subset of tests. Maybe if you're having a huge test suite and you just want to run the tests quicker, the tests that touch the part of the code that you're changing, then you can specify a cargo test and the substring that you would want to execute, and then every test function that contains that substring, that would be run. And this is really what the VS Code is doing when you click on that run test function. It's not ideal because if the test that you just clicked on, if its name is a string that is also a substring of the other tests, it would run those other tests as well. So you can obviously not in the VS Code, but like if you wanted to run just that particular test, you can use the exact attribute parameter. Or if you want to just run a particular type of test, so either the test of the library binary or the integration test, you can specify them with --lib --bin --test, potentially choosing which binary test or which integration test you want to run. Yeah, so that would be only everything what was mentioned in the chapter 11 of the Rust book. And let's just get into the building a command line program. And to be honest, it was kind of tricky to specify that in terms of the presentation. So what I eventually did is just I did follow that book with the Git, and I've been committing it, and we will just go through the change sets corresponding to different stages of implementing the program. But what the program was doing, or in this chapter, we basically were implementing the mini grep called mini grep program that works kind of like a simplified grep. It takes two arguments, positional arguments, the query input string, and the file path, file to the path that it needs to do the match against. And the expected output is that it will filter out the lines from that input path file that match the query input string. Yeah, and so to see the progress of that, let's just go and go through the change sets. So basically, the way how they approached it is that they initiated the project with the new binary crate. And obviously, when the new binary crate is being produced, it creates the whole binary structure, simplified structure. It would have cargo TOML with no dependencies on it. And they don't. The goal of that project was also that they wouldn't be using dependencies. And the first step that they did is they wrote a simple application that just got the input arguments, position arguments, and printed those input arguments. To do so, you just use standard crate or standard library with you're using the environment and the arguments function on it, and they got it into the vector of strings, and from the quick test they say basically that it is like with the C, most of the C programs, the argument 0 is the binary path to the application that's been executed. The first argument is at the first position, and then the second argument of the application is at the secondary position. So they created such a simple program, ran it, and they basically show that if you run it like with cargo run test sample txt, it would output the test searching for test string in the sample txt file. The second stage they did is they added the input file that they wanted to test on, that mini grep program. And they also added lines of code to read the string itself, to read the file itself. And for that, they used the file system module from the standard library to read into the string, so all the contents of the file name of the file to the memory. If anything fails, they basically said, "Oh, just panic with something went wrong" information. If that didn't fail, then print information that we got the contents of the text like so. When running that, we would still get the information about searching for the string token inside the poem text with the text as such. And the next stage that they were going through is they decided that right now the function is already doing, even though it's a small function, that it's doing already too much. So it's handling the parsing of the arguments, and then it's doing the the business logic of the application. So they decided to split that into, to extract the parse config function from the main, to which it takes the vector of the arguments, or a slice of strings. The function itself again knows that at the arguments 1 and arguments 2 there is a query in the file name, and it would be returning the query in the file name in the tuple. Obviously, you could say that it's a nice separation of concerns for the function, single responsibility principle. This function only worries about the parsing of the config. So yeah, nothing really changed in the main code. Just instead of having a separately defined variables, they distract the tuple into the query and the file name. And the next stage, they said, is that, hey, these query and the file name, they are not, they are kind of dependent on each other, or they are related to each other, right? So these are the configuration variables that are being passed to the program. So really from the readability of the application, we should be grouping them. So they started using the structure called config that would contain the query and the file name. And when they are parsing the function, now they would be creating a config structure with the query and the file name. So they did say that, oh, right now we cannot really be using just references to the input strings, because the lifetime of the config is not specified, and we didn't really like go through the lifetimes of the application or of the variables. So let's just clone the variables. It's a potential performance hit, but obviously in such an application, it doesn't matter. So they just clone the query, clone the file name, and transfer the ownership of those variables over to the config, structure, right? Inside the main, the only modification is that instead of right now calling query and the file name, you're calling to the query and the file name member variables of the config variable itself. Yeah, so the next step that they were going through is that they said, hey, this function is really a factory function, and idiomatic way of doing such a thing, so a factory function that creates a config, idiomatic way of doing such a thing in Rust is to create a new static function on the config structure itself. And yeah, they extracted that this way, and now the way how you call it is it conforms to all the other Rust structures, that you can just say config new, meaning create me a config class with the given parameters. The next step is that they said, hey, right now we want to add some error handling. So without that error handling, obviously, if you didn't specify enough arguments to run the application when it's being run, it would panic with the information that it's trying to access the vector, the slice outside of the of its bounds. So now they're giving it more meaningful information. The user would get information saying stack trace panic, whatever, not enough arguments, not very useful either, but it's already better than just the default ones. And then there would be another approach, because that panic is not really, it's not really nice. So basically they would say, hey, right now we would, instead of panicking, we want to return the error from the new config. And in case the number of arguments is enough, we want to return the config itself. And the way how you are doing it, you're just wrapping it up inside the result type. And the reason for them doing that is, first of all, that you don't want to be like writing the panic message, or you don't want to be panicking because it's not nice to the user of your application, but also they are willing to separate that code into the library, and it's not up to the library that should be deciding is the application to be panicking because there is not enough arguments being passed to it. So they're passing the responsibility of panicking or not, or doing anything else, to the main caller that is interacting with the IO world. And in such a case, they also basically said, okay, we're not going to be panicking. We're going to be printing out a nice information to the user, and then just using the process module, will be exiting with non-zero exit mode, status code. So that is like separation of concerns and trying to modularize the code. Then they basically said, how can I expand it? So they basically decided also to move the application logic itself also from outside from the main module, inside the run method. Nothing really fancy, but you will see that later on we will be able to extract all of this into the library itself, which is going to be testable. Next step, can see the difference. Yeah, so next step, they basically said, okay, now this function that we just extracted, it really can fail, right? And again, we would be just panicking. Again, it shouldn't be up to us if we should panic or not. So let's just use the file system read to string, but instead of us deciding and panicking, just propagate the error back to the caller. And the way how they did it is this time they used the result of nothing, because that function wasn't returning anything anyway, but they would be returning, in case of the error, the box of the dynamic error trait. And the reason why they're using the box of the dynamic error trait is that they don't have to really worry about what is being returned here. So they would return the error instead of nothing, potentially, and then it's up to the main on how to interact with the user, and the user can decide, or the main can decide that if there was an application error, again, we would print it nicely without the stack traces of the panic, and we would return non-zero return code. They didn't use much, but they used the let error. And the reason for that is we really didn't worry about what happens in the successful case. We just worry about what happens in the error case. And the next step is probably one of the more nice steps, is that all of that code that we were just extracting from main, it's been moved to the library itself. So library part of the crate. There hasn't been done really much apart from just extraction to the lib_rs with the necessary use statements. And then the adaptations of the main function itself are that now we're bringing it the config into the scope of this module, and they just decided to bring it with the full mini-grep config path, so that it can be used without any prefixes. But then the mini-grep itself is going to be called, so the run function itself is going to be called with the full path. the function. And yeah, there was no really like for them explanation, oh, should we be doing that, or should we be bringing in the path of the run? Oh, okay. I guess anyway, it's good to have at least one scoping name prefix. Yeah, so after they did that, they started running the TDD. So basically, they said, now we want to implement part of the application that is really gonna be taking the contents and then trying to look for the query lines. So they would be specifying how the signature of the function looks like. And then they wanted, they added the test that is basically testing for the correct behavior of such a function. And with the TDD approach, obviously, you add as much as you can to compile the code, you write the test, then the test should fail, and then in the next step, you would be implementing the test, the code to satisfy the test, right? And what they did is they just run a simple test. So the contents would be multi-line string consisting of Rust, safe, fast, productive, pick 3. And then they would try to assert that when querying for a query, which is duct, which is in that line only, so say running the duct on those contents, it would produce only that line. And obviously, like in a full production code, you would be testing for 0 results, for many results, potentially for some other edge conditions when the empty query is empty, when the contents are empty and whatnot. Obviously, that's a book that is limited in scope, right? Yeah, so the next thing they did is they wanted to implement the search function so that it satisfies the test itself. They did it in such a way that they're just iterating over all the lines of the contents and then trying to match if the query belongs to that line. If it does, then it will be pushed onto the new vector that they created. They did mention that obviously all of this is just the iterator filtering, so it could be expressed with the iterators much easier, but they're not doing it because the iterators haven't been covered yet. And once that function has been implemented, obviously in a TDD way, so now we really want to use it in the business logic of the application so that we get the lines that do match the query from the application, and then we would be printing those lines into the standard error. After that is done, they basically added some more requirements to the application saying, hey, what if we wanted to specify that we want to be reading the environment variable is case sensitive or not? And then depending on if that environment variable is set or not, we want to be matching like grep -i or without the -i. And for this, they introduced another function, which is search case insensitive function, which is doing the same as the search case sensitive function was doing, or search case function was doing. It's just this time they wanted to, when they're invoking that function, then the filtering of the lines should be case insensitive. One thing I noticed there is that in their examples, the search function was being exported as public, but and the search case sensitive insensitive functions was also exported as public, but obviously you don't have to make it public because you're using that inside the same module. So I didn't put the public keyword before that function. So they added the test, added the declaration of a function. It did fail when run. And sorry, it did fail when run. And then they implemented the function where they were just basically going to the query, so taking the query, shadowing it with the lowercase value of the query itself. And then for every line that they're iterating over, they're making it lowercase and checking if that lowercase query is contained. If it is contained, then pushing the non-lowercase line onto the vector. They did mention that it's not necessarily gonna be working for all the UTF-8 space, but it should be good enough for that particular test. Not gonna be covering that because that was just running the format. And the last thing that they basically did is implement using those functions, that function, search case insensitive, inside the run method that is executed main business logic of our application. And the way how they did it is that obviously they added the field case sensitive Boolean field into the config. They, because of the single responsibility principle, the config has changed. So the function that is parsing the config should also change. And that's the only reason why it should change, right? So now the function would be changed by checking if the environment variable case insensitive is existing or not. If it does exist, if it is set, then the error is false. If it doesn't exist, the error would be written in true, meaning that it is going to be case sensitive. That is being passed to the constructor of the config. And then during the execution of the main business logic run function, they would check if that case sensitive is set or not. And if it is set, then the search function would be called. If it wasn't set, then the search case insensitive function would be called, returning the results, and then they would be printing the results line by line. They did one more thing, but I must have skipped that the change set here. So basically, the last thing that they did is they would be printing. They said that they didn't want to print everything to the standard error output. So in case of the error, they should be following the nice practices of the Unix world, of any kind of command line application. So in case of the error, it should be printing into the standard error. In case of normal execution, so the lines being printed out, it should be printed to the standard output. And the way how they did change it is in the error case. Oh. So let me, I wonder if I have it or not. So in the error case, they wouldn't be using println macro, but there is println macro that is printing to the standard error. Yeah, and that was the whole 12.12 that was whole chapter 12, basically. I don't know. Yeah. And after all that implementation and everything has been done, that would be just the result of the application running case insensitive, being set with cargo run 2 token to the file being called poem.txt. It should be returning everything that is case insensitive, having 2 case insensitive. Yeah.
Nice. Thanks, Krzysztof.
It is pretty difficult really to present a chapter that is just implement a program. I realized. Hopefully that wasn't too bad.
I think doing it with Git worked really well. That's really, yeah. Who doesn't like seeing a diff in in Git? That's really good. I think with when you didn't add the pub keyword to the insensitive, I guess the use case there is if you were because you put it in a library, you could in theory publish that crate and someone else's calling code might want to call that code directly. Whereas in your code, you're only using it within your library itself. But if you publish that library, someone else might want to call just that method.
Mm-hmm.
So by not making it public, you wouldn't be able to, I don't think.
I get it, but you see, the problem is that by default, you should be making everything private, because once you make it public, maybe without thinking here, right? People start using it, and then you cannot change it.
Yes. Yeah. Yeah, definitely. Just think in terms of why they might have done it. That's all I think is that, yeah, they put it in a library for a reason. You can separate out your binary in your library, but the main reason you do that is so you can reuse the code.
Yeah, if I remember, they didn't say that, right? But maybe I missed it. Read it too many times.
They might have just done it by default. And they were thinking, this is a method I might want to use. So, but you're right, you should keep it private until that moment comes.
Yeah.
Sure, Krzysztof, sorry. I was going to say, between the comprehensive coverage that the book gives and your excellent presentation of it, I'm struggling to think of questions.
So it might be the case that it was just presented in such a way that no one knows what it was about.
I think it's far from that. I think you.
Yeah, I did. So also for the tests, like the test chapter, you do have to have a hands-on. Otherwise, it was written in a way that when I first read it, right, I wasn't like sure, oh, where those tests are, and then they're saying, oh, these are the functions. You just run cargo test, right, and then you get produced so much output. So I tried to split it into, oh, yeah, there is a dot test, doc test, integration test, right? Depending on locations, it will be detected. There is, like with Rust and with cargo, there's lots of conventions, right? You put RS file there, it's treated as a module. You put RS file there, it's treated as a test binary, right? Yeah.
Yeah, they have sort of come up with a number of conventions that they seem to be pretty well thought out. It'd be interesting to see how many they regret in future years or that they end up going back on. But yeah, like with their test harness, an awful lot of it seems to have learned a lot of lessons from previous languages and environments.
Definitely. I mean, also the test function is just, the function that you run. If it executes okay, it's fine, right? If it errors, then yeah, it's an error. But obviously, like with the C++, which wasn't created in the world that the tests were very prevalent, right? So then you would have to have Google tests catch to that do their own trickiness to do the resolution of the tests, right? Whereas Rust just has this test attribute, and the test lib that is the default runner of the test suites in cargo, right? It would just inspect the code. Oh yeah, there is a test function, this, and this. I will run them, right? One of the things is that you can swap out the test lib, so you can have your own test harness if you wanted to. Not really sure how and why would you would want that, but you can.
You mean if someone publishes a crate and they publish their test modules along with it, you could pull down the crate but then build your own tests against it instead?
Yeah, maybe.
I wasn't even sure if people generally published their test crates along with their actual library crates.
Normally you'd put the tests up with your crates, but yeah,
definitely it's encouraged, right? And yes. Also like in the open source world, you definitely want to have as much tests as you wanted, right? And like the code of conducts on the projects are saying if you implement something new, it has to be covered with the tests, right? So yeah, like I cannot really think why you wouldn't want to have tests included in your crate, but maybe there are some security concerns. Don't know.
Yeah, don't remember. Well, not security. I just thinking. I knew that it was encouraged to push your tests up with your crate, and that I thought they ran it regularly, daily, or on submission, so that you couldn't. That it would regularly flag crates whose tests were failing, and this was all part of. They would rerun through all the crates whenever they changed the compiler, so they would make sure. Verify how many crates they're building, but because they're running the tests so much and are so making sure that all the crates are clean, it almost makes it unnecessary for individual users to pull down the tests and rerun them. You're pulling down something that's already being tested all the time.
Oh, okay. So it's like to minimize the number of bytes you're using. Yeah, maybe that's true.
Well, actually, when you pull it in with your cargo toml, actually, I would think it doesn't pull the source at that point, so it would pull down the release binaries, which wouldn't have the test code built into it anyway. So even though you've published it with your test,
so you can have, right? So the unit tests. You would have the unit test lines of code in there, right? It's embedded inside your binary and library code. If you're pulling, yeah. So you still pay for the network traffic.
I have another option, because there's few ways how we can include the crates. So it might be the crate from repository, or it might be directly from the GitHub, or even from your local directory. So if you have the test everywhere and with the crates, then you can make the same code just switching it as a dependency in the cargo toml, and it's working with every crate from the local, from GitHub across this repository one.
So saying you could run the tests against different like
Yes,
copies of the same
sometimes
crate.
you wanna fix patch it Ilya, or just use this one from the main branch, which isn't published yet.
Yeah, yeah, maybe. That obviously is not anything Rust specific, right? So if you follow such an approach, you would be doing something like this probably in other languages as well. Yeah, maybe it is something that people are doing. Obviously, we don't know all the use cases, right?
I guess the nice thing about Rust is with all these kind of idiomatic things like, oh, you put it in this folder and you do it this way, those are to make our lives easier. They're not baked into the language, they're baked into cargo.
Yeah.
So we kind of think of them as all being intertwined, but there's no reason why in the future it couldn't break away. All the code would still work. It's just, currently that's the idiomatic way to compile it. And that makes our lives much easier because it's just one way that everyone does it. And you can pull down, someone else's crate and it's not going to take you 3 hours of reading documentation to get it to build on your machine. It'll just work.
Which is C++ problem potentially, right?
Yeah.
Yeah, if you have conventions of doing things, then the person joining the project straight away starts without like a huge learning curve, right? If every project is doing things on its own, basic things like compiling, running tests and whatnot, right? There are no conventions. Then you join the project and you just spend a week or whatnot to get to know how all of this is done.
Yeah.
I personally like conventions.
You need a good reason to break from them.
Yeah. When going through the tests section of the book itself, right? I think a useful thing for me was also reading the cargo book section on tests, and there is also Rust by example book, which also has section on tests. And yeah, for me, after reading all those three, it got much clearer. So each of them mentions like, oh yeah, there is a test lib, right? So cargo book says there is a like this is interesting, right? So you have, let's say, for the integration tests, you have a file that only contains the test functions and the helper functions, and potentially links to the modules, right? With code reuse, and you know, it's getting converted into the standalone thing that is getting run, a binary, right? And they say, oh, it is because there is a test lib that we run link against, and this has the main entry. I mean, it's the same as probably every test framework on C++ is doing, C doing it, right? Like GTest definitely is doing something like that. So you can opt in having your own main function, or you can opt in and saying just use the main from the library itself. But yeah, getting to know a bit more on how everything works inside, I think it makes easier to be using it.
Less black magic.
Also like the I don't remember which one was that. I think it was Rust by example. It has examples of writing CI scripts for things like GitLab, GitHub Actions, I think it was as well. So you know, you can just copy over that code. Travis, you can copy over that code and start from something, and yeah, you can basically have the code being executed there. I was thinking about adding it into the presentation, but it was already too much. I think I ran over anyway.
Future session.
Yeah, yeah.
Yeah, we're always looking for more topics at the non-book club meetups, Krzysztof. So
yeah. Also,
sounds like
like
you volunteered.
So there is another thing, maybe why the runner you would swap out to other runners, right? So cargo test is able to produce like this textual output. I think in the nightly build it can produce something JSON formatted, but lots of the tools analyzing the tests results, they expect the JUnit format, which is XML format. So you potentially can run either your own test harness that is producing that, or I think also there is a crate that you can use to convert output from the tests run by cargo test to the JUnit format. And you know, this is useful because then, for instance, like on GitLab, you can consume the JUnit results and present them in like a visual graphical dashboard on the graphical dashboard. Just yeah, to make everything easier probably for users.
Also, I'm just gonna steal the screen share, Krzysztof, just because we are starting to run low on time. But thank you very much for taking the lead on both those chapters. I'm sure I speak for everyone and say it's very much appreciated, and we've learned a lot. So with chapters in mind, so the plan is to cover the next two chapters, 13 and 14, in 2 weeks' time. And then 2 weeks from then, we're looking to cover chapters 15 and 16. So if anyone else is interested in following Krzysztof's example and talking us through those chapters, I'm going to I'm going to post the link to the Discord again in the chat shortly, just to make sure it's the latest and greatest link. There we are. I think we already have one volunteer for our next session, but for chapters 15 and 16 are still up for grabs if anyone's particularly keen.
With the chapters, if the chapter seems a bit meaty, so like the smart pointers one, for example, we might want to do a whole session on it, possibly. It depends how much detail, I need to remind myself how much detail the book goes into. But it's something that we're going to want to focus on. The mutability pattern in Rust is a bit different to C++, and I know we've got folks who are coming not from C++ as well, which then would be a whole other ball game, and I think it's quite an important one. So we maybe will split those two out. But yeah, if anyone wants to take the lead on it, we can send like templates for slides if that's helpful as well. Most of us use Markdown to write it, which seems to be the quickest way to write slides these days if you write Markdown for other reasons.
Yeah, thank you for that, Kira. So yeah, just just some actual specifics on those dates. So 13 and 14 in 2 weeks' time will be the 20th of January. And then we've got 2 weeks after that, which is chapters 15 and possibly 16, depending on how meaty we find chapter 15. That'll be on the 3rd. And then we're looking to have a non-book club meetup on the 10th of February, which we've earmarked for C++ topics, but really that could be C++ or Rust. So Krzysztof, looking at you. But if anyone else has any ideas for a talk that they'd like to give, we'd encourage them to get involved and volunteer themselves. Feel free to get in touch with us on Discord or any of the other mediums, Twitter or email. And I think that's everything for housekeeping. Yes, it is. Excellent.
Thanks, Alex.
Yeah, I think we also said that we not necessarily have to follow the book to the from like exactly, right? So if there is something more interesting on the particular topic, we can extend it, I guess.
Mm-hmm.
And the smart pointers is the thing that can be interesting, right?
Absolutely. Yeah, these are all just sort of rough plans. Everything is flexible. Everything is negotiable. So I suppose really, if you volunteer to lead the book club, you get to decide. Think about it that way.
You get the power.
You get the power, exactly.
So yeah, just message like Alex or Krzysztof or me or yeah, and we'll put you down and for it, because it's yeah. How did you find it, Krzysztof? How did you enjoy making the slides and stuff? This style of meetup.
I mean, yeah, it's so I think when you follow the book, it's easier. But then when you try like, oh yeah, let's do that way, I'm just usually getting into a rabbit hole, and that was the case.
Is that not a good thing though? It kind of forces you to read around a bit.
Yeah, but it depends how much time you have, right?
Yeah.
I'm also on the quarantine, so we do rotas, working rotas with my wife, and then the other one is taking care of our boy, and just there is no time for anything else.
We won't put you down for the smart pointers then.
I mean, it's only 7 or 10 days, right? So.
Right, I've got to shoot on. See you all next time.
All right.
Thanks for
guys.
coming, everyone. Bye-bye.
Have a good
Thank
evening.
you. Bye.
Bye-bye.
See you soon.
See you soon.